Okay, guys. Today we are going to learn matrix multiplication. There's two types of matrix multiplication, okay? There's something called scalar multiplication, and then there is something called matrix multiplication. Let's first look at how scalar multiplication works. It's very simple. Scalar multiplication is very easy if you distribute the value being multiplied to the matrix, to each element within the matrix. For example, I have matrix A here, okay? And matrix A, remember what these things mean? This little A11 means row 1, column 1. This guy here is row 2, column 2, row 1, column 2, and row 2, column 2, okay? And this I messed up. It's row 2, column 1. All right. So if I take that matrix and I multiply by n, that is called scalar multiplication. Basically what I'm doing to a matrix when I'm doing scalar multiplication, I'm either increasing it, expanding it by a lot, or I am decreasing the values. So in this particular case, as you can see, n is distributed to everything inside. Everything. Does that make sense?
Yes.
Okay. Let's show you an example. I have matrix A and matrix B. I want to find, excuse me, 2A plus 3B. So I want to find 2A plus 3B. So okay, let's go ahead and take this. Let me clone this guy here. Actually, let me go ahead. Just make my life easier. Okay. So 2A and plus 3B. All right, well, this is going to be very, very easy, just a little bit of time consuming. So when I have 2 times matrix A, I'm going to distribute that 2 to every single element. 6, negative 2, 12, 8, 16, bless you. Negative 10, 4, 10, and 14. And then plus 3 times B, negative 6, 9, 6, negative 9, 12, 6, 12, negative 18, and 27. All right. Let me give us some space. Bless you. Okay, so now let's add them together. My sum here will be 6 minus 6, 0. Negative 2 plus 9, 7. 18, negative 1. 28, negative 4. 16, negative 8. And 41. Done, done, and done. Does that make sense? Okay. Come again? 41. 41, sir. Now, we can use these skills to go ahead and solve equations as well. First of all, excuse me, I'm not feeling very well today. I've got 3x plus scalar multiplication. So I'm going to make this 8, negative 4, 12, 16 equals 17, 5, negative 3, 1. I want to solve for x, so I got to get x alone. So I'm going to subtract this matrix here to both sides. And remember, when I subtract a matrix, I like to distribute that negative everywhere. So I'm going to have 3x equals 17 minus 8, that's 9. Then I got 9, negative 15, and negative 15. Give me 1 second. Okay, so now, division is the same thing as multiplication, except, of course, it's reversed. So for scalar multiplication, I had to multiply everything by what I was multiplying the matrix by. When I'm dividing, what do you think you're going to do with that value? Divide this to every single thing. So this is going to be 3, 3, negative 5, negative 5, and that is your answer. Sir?
When you divide, it doesn't go in evenly, you put a fraction.
If it does not divide and it does not go in evenly, then yes, you can put a fraction. Yes, sir. Thank you, my brother. Makes sense, right? Pretty easy? All right, let's move on. Now that we understand how scalar multiplication works, let's focus on matrix multiplication. In order to multiply matrices, the number of columns of the first matrix must equal the number of rows of the second matrix. Okay, please be careful with that. And the product will equal the first matrix's rows times the second matrix's rows. Okay. Let's first talk about how do we realize whether or not they can be multiplied. The columns of the first one have to be equal to the rows of the second one. Notice how I made this in red. Remember that this is rows, columns. The columns, there's 1, 2, 3 columns, must equal the rows of the second one. There's 1, 2, 3 rows. So 3 columns, 3 rows, you can go. You have to make sure that the columns of the first equals the columns of the rows of the second. If you don't have that, you cannot do it. Since you are multiplying here a 3 by 3 times a 3 by 2, you are allowed to multiply the matrices. If you think about it, the last number must equal the first number. Okay? The columns of the first factor must equal the rows of the second factor. That is the number one important part here. Most people mess up because they forget that. And you'll see that if you forget that, you're going to get really stuck while you're doing the process I'm about to teach you. Because you cannot work this process unless you have the columns of the first factor equal to the rows of the second factor. Everyone with me so far? Yes, sir. If they're not equal, then you cannot multiply them. Correct. For example, if I was trying to multiply a 3 by 4 and a 5 by 4, does this column equal this row? No. So you cannot multiply those. That would just be impossible. You wouldn't say no solution. You would just say not possible. Does that make sense, sir? Thank you, son. Okay. So let's see how it works. All right. Very simple. Just pay attention. Please, please pay attention to this, okay? When you're multiplying this, the first term, okay, gets multiplied to the first term of the second matrix. You with me? Then the next term, in the second column, gets multiplied to the second row of the first column. You with me? That's what I did right here. A11 times B11 plus A12 times B21. You with me so far? Then A11 times B12. And then A12 times B22. That's this guy. Does that make sense? So just to make sure we got this, let's go over this again. It's the first term times the first term of the second matrix. first term in the second column of the first matrix times the second value in the first column of the second matrix. Then you repeat the same thing, but with the second column of matrix 2. So you're going to have A11, the first term, times B12. Then A12 times B22. Is everyone with me so far? And that little red sum is right here. Now, A21 times B11. Then A22 times B21. That's my green one right there. And last but not least, A21 times B12. A22 times B22. And then you add up each of those, and you're going to have a matrix left over. That is a 2 by 2. You with me so far? You sure? Okay. Before you begin multiplying matrices, though, please, you must make sure that they meet the dimensions criteria. So before we even start practicing this, let's see if you guys understand what that means. Determine if each pair of matrices given by dimensions can be multiplied. Can I multiply A? No, the columns do not equal the rows. No. How about B?
Yes.
Columns equals the row. Yes. C? Columns equal the rows. Yes. D? Columns do not equal the rows. No. We're good? Okay. Let's knock this out then. Determine the product of each. Okay, guys. Follow my lead. Okay? Follow my lead. Yeah, make a little thing like this. 2 times 4 is 8. And then negative 1 times 2 is negative 2. You with me? That's your first value. We're good? Now, 2 times 5 is 10. Negative 1 times 7 is negative 7. That's my second value. Yes? Then, 1 times 4 and 3 times 2. My third value. And then 1 times 5, 3 plus 3 times 7. So now my answer is going to be 6, 3, 10, 26. That makes sense. Takes a little bit of time, but that makes sense. You see where you were making your mistake now? Thank you, my brother. Okay, let's try this next one. This is a 2 by 2, and this is a 2 by 1. Can I do it?
Yes.
Absolutely. So check it out, guys. Well, first of all, first value, 1 times 4, and then 4 times negative 5. That's my first value. You cool? Okay. I'm going to erase it so it doesn't get so confusing. Then, excuse me. Then 2 times 4, right? And then negative 3 times negative 5, which is 15. So I'm going to have negative 16 and 23. You with me? Yes, sir.
So, if they are able to be multiplied, the product would be the second matrix, the dimensions of the second matrix.
That's a great question. I swear I was just going to go to that right now. This here is a 2 by 2, right, my brothers? And this one here is a 2 by 1, right, my brothers? Check this out, guys. Don't you take the inners to see if you can multiply them? Okay. If you can multiply them, I promise you, the outside dimensions will always equal the product. So in this case, you have a 2 by 1, right? Isn't this a 2 by 1? With me? How about up here? Up here you had a 2 by 2 times a 2 by 2. Well, you tested the inside values here, the rows and the columns. They were equal. I have my answer. Wow, but my answer is a 2 by 2, Mr. Morrow. Yeah, it should be. Because what do you have? A 2 by 2 left over. Does that make sense? Promise? Okay. How about C? Can't. This is a 2 by 2, and this is a 1 by 2. These guys do not match. The rows of the first do not match the columns of the columns of the first do not match the rows of the second. So no, can't do it. Not possible. Does that make sense? Okay. And wow, that's awesome. That was faster than I had anticipated. Awesome. We're good. We're golden. Yeah, we're going to practice right now. Any questions, though? Any questions on this stuff, guys? So far? We're good? Okay. Thank you very much. God bless you.